Here we have an electrocardiogram, which can be called an ECG or EKG for short. Remember when we did that graph comparing the electrical activities of skeletal muscle to cardiac muscle? That's what an EKG shows. It is the electrical activity of the cardiac muscle. So remember we had depolarization, plateau, repolarization. So the muscle cell, and again, if you need to, look back at those two graphs, the side-by-side comparison of the skeletal and cardiac muscle. You depolarize by sodium coming in, and you raise your voltage. Then you have plateau, where you have calcium in and potassium out at the same time. And this gives you kind of a slowly falling voltage. It's pretty steady. Then you have repolarization, where you just have potassium out, so the calcium gates close, and that decreases your voltage back to your resting membrane potential. Remember, during plateau is when you have systole. Muscle contracts during plateau. And remember that the heartbeat occurs in 2 steps. So you're going to do this twice. First for the atria, second for the ventricles. So this graph is electrodes picking up these activities, depolarization, plateau, repolarization in the cardiac muscle. And I've already color-coded this graph. I color-coded it to match what we have up here in the last set of notes you took, because the electrical activities correspond with the different parts of the cardiac cycle. So we're going to start off. Our first thing up here was early diastole, when the heart is relaxed. So notice that's at the end. So like here and here are when the heart is in early diastole. So this is when the heart is between beats and it starts to fill with blood. Now this graph repeats. So the reason I have something at the end and again at the beginning is there would be another beginning here. Like we could actually continue this on. This graph just keeps going and repeating. So when you get to the end, you go back to the beginning. So this part here that I have marked as the beginning would be right here. It would come right after the end. So the early diastole is this area between the heartbeats, when the heart's relaxed and it's beginning to fill with blood. Okay. Then we have our late diastole. So that's the purple. So here on the graph, this is the P wave. P wave is the atria depolarize. So remember, depolarization happens before the systole. So just before the atria contract, they have to depolarize. So this is when sodium is entering the myocardial cells of the atria and raising their voltage. That rise in voltage of the atrial cells is what you see as this P wave. And this occurs as the signal moves from the SA node to the AV node. Remember, as the signal's moving from the SA to the AV, it spreads through the gap junctions and depolarizes all of the atrial myocardial cells. Okay, then after you depolarize, the next thing you have is plateau and systole. So that is the atrial systole. This part is called the PQ segment. So the PQ segment shows us the atria in plateau. And this is when they systole. So this is when you have calcium in, potassium out, steady voltage, and they contract. You have atrial systole at this time. And so you push the rest of the blood into the ventricles. Then next, the ventricles have to contract. So I used green here, and we don't have green up here, because there's not really a picture here that kind of corresponds with it. So it would just go like right here in between these steps. So this is QRS. So this is called the QRS complex. This is when the ventricles depolarize. So now in the ventricles you have sodium in and voltage going up. Then next you have the ventricle systole. And up here we split it into two parts. We have the yellow for the early and the blue for the late. So this part down here is the ST segment. So you can pick if you want to write that in yellow or write it in blue or half and half. I'll just go ahead and put it in yellow, make it a little easier. But next you have the ST segment. This is when the ventricles are in plateau. So they have calcium in, potassium out, and the voltage is steady, and you have ventricular systole. Okay, then after plateau comes repolarization. So now we have the ventricles repolarize. This is the T wave. So now you have just potassium out and your voltage goes down and the heart is relaxed. So now you are in diastole, where you again begin to refill with blood. And then you would go back to another P wave. So remember, it's a repeating cycle. So then you would have another P wave. So this would be our next P wave right here, and you would just keep repeating. Okay, so we have P wave, the atria depolarize, PQ segment, the atria plateau and systole, QRS complex, the ventricles depolarize, ST segment, the ventricles plateau and systole, T wave, the ventricles repolarize. So we're going through these three steps. We have it once for the atria, a second time for the ventricles. So you might be noticing something missing. If I said we're going through these three steps, so we have atria depolarize at the P wave, plateau at the PQ segment. Then we jump up to the QRS complex with the ventricles depolarizing. We skipped atria repolarizing. There is a reason we skip that. It does happen, but it's not shown here. So atria do repolarize. But they do so at the same time as the ventricles depolarize. So you have two events occurring at the same time. We can't put both on the graph. So we see the QRS that represents the ventricles depolarizing. The atria are repolarizing during this time, but you can't look at two things at the same time. So we look at the ventricles depolarizing. So to kind of sum this up, you have, compare it to what we started with here, you have atria depolarize, that's the P wave. Then you have atria plateau, that's the PQ segment. Then we have the ventricles depolarize and the atria repolarize at the same time. That's the QRS. Then we go into the ventricles plateau, then the ventricles repolarize. There's your steps.